Hi everyone, a cable calculation question again. This one is aimed at the level 2 students where we are just going to calculate the size of the live cable and we will only be using our on-site guide. So on your screen you can see the question. It's got a diagram with lots of information and some text underneath. The question finishes by saying evaluate this design. So the circuit has been designed and we need to confirm whether this complies with BSM 671 or whether it does not. And if it does not, we can then offer our recommendations. So looking at the picture, we've got a three-phase supply coming from the substation to the meter to the main switch. Then we've got a type B MCB, and then we have a single phase supply. It says it's 1 mil singles. The circuit length is 56 meters. Single phase and live neutral earth. And then in the question it says it is a new lighting circuit. So I'm going to start by looking at the diagram and writing down all the information that gives me and writing down all the information that I need from the text. So let's make a start. So at the top right hand side of my paper we'll start with MCB B, that's what it wants me to use, and we've got 1 mil singles, length is 56 meters, and now we're down into the text. So it's a lighting circuit installed in a three-phase electrical installation with the workshop. The circuit will be run inside trunking. So there's my install method, inside trunking, 3 other circuits. So along with mine that is 4 circuits total. And it'll be run with the 3 other circuits for 10 meters within the workshop. So although it's only ran for 10 meters with these 3 other circuits, when we're doing a cable calculation we must always take the worst case scenario. So we will assume, or we will just continue our calculation as though that it is always run with 3 other circuits. And then we've got a temperature there, 35 degrees. And for 100 mil of the trunking passes through a section of roofing and is completely surrounded by insulation. So that is our CI. And that is 100 mil. What else have we got? Then underneath the circuit will be connected to 8 times, so power is 8 times 80. Fluorescent light fitting supplies a TNCS, and ZE equals 0.32. So that is all of the information that the texts give us. So now we can make a start on our cable calculations. So hopefully you've been to the website and you have joined where you can then download the cable calculation step-by-step guide, and if you have, we are going to be doing steps 1 through to 8. So let's make a start. So our first thing we need to do is IB. IB. Now IB normally equals power divide volts. So my power would be 8 times 80 divide 230. But because these are fluorescent lights, there's something else we need to look at. So let's go to our on-site guide, and if we look at our diversity tab, maximum demand of diversity, turn the page and have a look at page 136. Under the table in note 2, here, note 2. It says final circuits for discharge lighting. And right the way down towards the bottom, it says multiplied by not less than 1.8. Now this is to do with the power factor correction for the control gear that we have within fluorescent lighting. So our equation then becomes, or our power becomes 8 times 80 times 1.8 over 230. And that equals, that would be 1152 divided 230, and that equals 5 amps. I think it's 5.0089, something like that. So we'll just round that to 5. Here's my IB, 5 amps. Now we move on to find our IN. So we're now back over to the on-site guide. Go to my IN tab. IN tab, and we are on page 75. Now this table goes on for quite a few pages, and it's lots of information that we don't actually need. We are going to look at columns 1 and 2. It says protective device. So we want a shopping list that tells us what are the sizes of MCBs that we can buy, and this table provides just that. Column 2 shows you what type of protective device you're using. Is it an MCB, a 3036 or an 88? And column 1 shows you the size, the amp rating. So our IN was 5. We need, IB, sorry, was 5. We need an IN that is 5 or slightly above. And we need it to be a type B MCB. So if I turn the page, I've got, oh brilliant, I've got a 5 amp here, but it says they only make a 3036 and a BS88-3 in a 5 amp. Next up there is a 6 amp, and they do make an MCB in a 6 amp. So brilliant, that will be the one we choose. So my IN is 6 amps. That is a type B MCB, and we reference the table that we got that from. That is table 7.1 II. Now we're looking at our C factors. So let's go through our questions. So we've got all the information we've got. So 4 circuits. So that is CG. Let's go to our CG table. CG table. That is table 3F, F3, sorry, on page 170. And the top row says bunched in the air on a surface embedded or enclosed. Enclosed means enclosed in conduit, enclosed in trunking. We are in trunking. So on the top row we've got 4 circuits in total, and that will be 0.65. And again reference the table, table 3F. And then we had ambient temperature, that's on the page beforehand. So we're now looking at table F1. And we have, let's look at column 1 is ambient temperature, column 2 70 degree thermoplastic, column 3 90 degree thermosetting cable, and columns 4 and 5 are for mineral insulated cable, MI. So our question says we are using 70 degree thermoplastic. So we are looking at column 1 and 2. Now our question said it was 35 degrees. So our CA factor, 35 degrees, is 0.94. Reference the table, table F1. And the next C factor we come to in our question was CI. Our cable, our trunking, was completely surrounded by 100 mil of thermal insulation. So that is on page 169 of the on-site guide, this small table here. And the length of insulation, 100 mil. It says our C factor is 0.78. Go ahead and draw that, 0.78. Reference the table, table F2. Now we can put that into our IZ calculation. So our IZ equals IN over any and all C factors that are relevant to our question. So for our question, we've got CA, CG, CI. So let's input those values. So our IN was 6. And we've got 6 over 0.65 times 0.94 times 0.78. If we punch that into our calculator, with a little bit of rounding, we end up with 12.6 amps. So, now we need to look at our IT. Our IT. Now our IT must be equal to 12.6 or greater than. So let's have a look at our IT table. So that's just the next page over. So we're now going to look at page 171. So we need to know our reference method. So reference method A says enclosed conduit, which ours is in thermally insulating wall. Ours isn't in a thermally insulating wall, it just passes through a short bit of thermal insulation. So we are reference method B, enclosed in conduit, on a wall or in trunking. So we are now looking at columns 4 and 5. Column 4 says single phase, column 5 says 3 phase. So we're in column 4 and we need 12.6 or above. And straight away I come to 13.5. So that is my IT value, and if I now look at column 1, I can see this cable size, that is 1mm cable. So let's go ahead and write those values down. So that was IT is 13.5, and I had 1mm cable, and reference the table, table F4I. Now we're going to find out our MVAM value. So it's another piece of paper. Let's leave that so we've got MVAM. MVAM. So back to our on-site guide. Turn the page to our MVAM table. We're on page 173. And our reference method, we was reference method B. So that is column 3. You see reference methods A and B, enclosed in conduit or in trunking, reference method B. And we had 1mm cable. So our MVAM is 44. Let's jot that down. MVAM 44. Table F4II. Now we look at our volt drop. Let's write volt drop. That is back a couple of pages. Turn to page 168 and you have your volt drop formula. So volt drop equals MVAM times IB times length over 1000. So let's put those values in. So 44 times IB, that was 5 times my length. What was that? 56 over 1000. Punch that into a calculator and we'll get 12.32 volts. Now what does this mean, this value, 12.32, my volt drop? Is that good? Is that bad? Well, let's have a look. Back to the volt drop section. If you look in the paragraph below the volt drop formula, we have some explanation there. On the second line down it says a lighting point does not exceed 3% of the nominal voltage, 6.9 volts. That 6.9 volts is 3% of 230. The book has done that equation for us just quickly. So our maximum volt drop in a lighting circuit, which ours is 6.9 volts. So we can write here, to gain those extra marks, max allowed is 6.9 volts. So obviously we've got a problem there. Ours is too great. Now, we've got to go back a few steps. We need to go back to our IT. The reason we're doing this is our volt drop formula is made up of MVAM, IN and length. I can't change my IB. I can't change my IB. I can't change my length. I can't change the number 1000. The only value we can change is this MVAM, this 44. And the only way to change the MVAM value is to change the cable size. So we go back to IT. So let's have a look back to our IT table. And all we do is we go to the next cable up. Now we had 1mm cable, so now we go to 1.5mm cable. Same column, we're still in column 4. So my IT now becomes 17.5 and I have 1.5mm cable. Reference the table again, table F4I, and the MVAM becomes, look at the MVAM table. MVAM, we are column 3, reference method B, column 3, we go to 1.5mm cable on column 1 and it gives my MVAM as 29. So MVAM now becomes 29. Reference the table again, table F4II. Now we can do another volt drop formula. So my volt drop equals MVAM 29 times IB, which is 5 times length, 56 over 1000. So punch that into your calculator and you should get 8.12 volts. And now we've got the same problem. So let's again write max allowed is 6.9 volts. The same problem. So then we just do exactly the same process. So back to IT, back to my IT table, and we go the next cable up. Now we will just keep on doing this until our volt drop works. So my next cable size up is 2.5. Sticking in column 4, my IT is 24. Jot that down. IT 24, 2.5mm cable, table F4I. Now MVAM, VAM, back to the MVAM table. MVAM, we are sticking in column 3, we're now down to 2.5mm cable, and you will see the MVAM is 18. 18, and our table F4II. I'll do our volt drop formula again. I'm hoping this will work because I'm a bit tired of doing the volt drop formula. It's a big one to type into your calculator. So 18 times IB was 5 times length, 56, sorry, over 1,000 equals, punch that into our calculator and we get 5.05. Finally, we've done it. And again, I'm kind of running out of space here, but again, right, max allowed is 6.9 volts. So, it's a little bit of a long-winded process, but we're showing the examiner that we know what our maximum allowed is at each step. This shows him that we understand what this volt drop value means, and we always make sure, I know it's a little bit laborious, but we do it every single time, reference every single table that we use. But we finally found our volt drop. So we are now at the correct size cable, which was 2.5. So now my volt drop works, I can move on to the final step in cable calculation, which is not really a formula, it's more of a statement, isn't it? We do IB is equal to or less than IN, which is equal to or less than IT. So if we input our values to make sure that reads true, IB was 5, my IN was 6, my IT was 24. So is 5 equal to or less than 6, which it is, and is 6 equal to or less than 24, which it is. That is correct. So that means we have chosen the correct size cable. So to answer the question, we've shown that the 1mm cable is incorrect. So we would say, to answer the question, 1mm cable does not comply with BS7671. And then we will add another little sentence. My calculations show 2.5mm cable would comply. And there you have it, guys. So we've been given a design and we've now evaluated it, and for this one the cable has been too small because we had a volt drop problem. And our final short sentences here show that to the examiner. 1mm cable does not comply, 2.5mm does. And there you have it. How we do a cable calculation working out the size of the live conductor only using the on-site guide. Thank you for watching the video. Remember, we've got plenty of other videos on all of the other tests that you can do, and there are also many videos on cable calculations and all sorts of things that you're going to need to know to complete level 2 and level 3 in electrical installation. Now, if you want my tabs that I have on my BS7671, visit the website electricalstudent.co.uk where you can purchase those. Also on the website, loads of free stuff, loads of practice tests, mock exam questions and such like. Working with electrical installation, guys, remember, be safe. Most importantly, listen to your lecturers. He or she definitely knows best. Take care, guys. See you soon.